Okay, 3.7.20. Let's take a look at this one. Doesn't quite look like a quadratic. See how that's a little bit flatter? So that would seem to me that that definitely has more of the shape of, if you watched one of the previous videos where I talked about the x to the fourth, how when you're within 1 unit here, so like you have a fraction, if you take a fraction and you raise it to the 4th power, so if this is my x squared sort of thing, maybe that's not quite wide enough, but let's say it's more like, but when you take a fraction, like 1/2, and you square it, that's 1/4. But when you take a fraction like 1/2 and you raise it to the 4th power, that's 1/16. So this actually gets smaller than this. So it's not growing as fast. So what you have to do when you get in here for the 4th degree, it's going to actually grow slower than the quadratic. But once you get beyond 1, so if you had like 1.25, I think that's what I used as my example, and the other one, to the 4th power and the 1.25 to the 2nd power, and you look at how those grow, you'll actually see that once you're past 1, this one ends up being 2.44-ish, squiggly sign for approximate. And down here, this one rounded off is more like 1.56. So once you get over 1, the 4th degree does grow faster, so it's going to be steeper. So anyway, back over here to our problem. Looks like it's a y to the 4th. I'm sorry, x to the 4th. It's been moved to the right 4, so remember that's the opposite of what you would think. X minus 4, I would think left, but minus 4 is to the right. Up 16 is out here. And then when I go over 1 here, so there's 5, that's 1. I am not going up 1 for that one. So when you will go over 1, you should go up 1 because 1 to the 4th power should still be 1 like there. So this does have some sort of stretch on it. To me, it looks like it hits right there at those coordinates. So if I want to find this out, what the stretch is in there, I'm going to put a variable out here because that's where my stretch goes. And now if we substitute in another point that we know here, if this is indeed 6 and 30, that point right there, I believe, there's my 6, and then there's 30. So if I put that in, 30 for my y, and 6 for my x, and now we'll just solve this to see what the stretch factor is before we get the final equation here. Oh, they did tell us it was a quartic. I was just going by how it looked. And then, let's see here. So, I've got 30 equals 2 to the 4th. 6 minus 4 is 2 to the 4th is 16 times that a plus 16. So, move this to the other side. Subtracting that 16, that gives me 14 over here. And divide by this 16. So if I take that 14/16, reduce that, since 2 divides into both of those evenly, to a 7/8, and I take that 7/8 and put it right there in place of that a, that should give me my final equation for this of 7/8 quantity x minus 4 squared plus 16. So do your transformations left and right, up and down, get it written in the general form with that. If it has right on a grid line, get those coordinates, put the x and the y, leave a stretch factor variable here, plug it in, solve for that stretch factor, substitute that back in for this variable, And you have your final equation with all of the possible or all the different parameters that changed the original shape of that graph.